I write a compiler for a small imperative programming language called Elna. The compiler is self-hosted and written in itself in several stages, and in each stage I can only use features that are already implemented in the previous stages. So the language that I'm currently writing is not the final version of the language, but is actually work in progress. And the language has two intermediate representation, not really two. The one is 3 address code, and the other one is the representation of the assembly. And each of these representations, the main part of them is an instruction, and each procedure or function contains a list of instructions. And my list implementation was not that good at the beginning, because I just had each instruction had a member next, and next referred to the next instruction. So it was a singly linked list, and now I modify or rewrite this list representation in a bit different form. So I have a new structure that is called Elna list, and this Elna list contains nodes, where nodes will be the instructions. So it contains first and last nodes. Actually, the only difference that I now keep a reference to the last element in this list, because I want to iterate the list beginning with the first element, and I want to be able to append things to the list there very quickly, just by using the last element instead of iterating the whole list each time I want to append something to it. I already modified the 3 address code generations, so that this representation already uses this new list structure, and now I'm going also to do the same for the assembly generation, so that assembly instructions are also saved in this new list structure. It is a tedious and a bit boring work, I suppose, but this list implementation is faster and less error prone, which is very important, because I already had bugs or problem where I appended elements wrongly and created circular lists and stuff like this, and the new structure will help with that. So I'm going to introduce it also into the assembly generation, so that the compiler is a bit less error prone, and I can better work with it. Somewhere we should have a function like RTL procedure declaration, probably, and this RTL procedure declaration, so here we have this body element. We visit first the parameters, and then we visit the body of the procedure. So I I will just define a new variable. We will call it body list, and this body list variable will have the type pointer to Elna list, and it will later replace these two variables, body and parameters. And I think that we can start with parameters, and we just pass a reference or a pointer to this body list variable to this function. I will split the screen in two parts, and we will navigate then to this Elna RTL procedure, Elna RTL parameters. So, and we will define a new parameter or argument and call it instructions. It is actually the result of this procedure, and this instruction is a pointer to an Elna list. So, and here we visit in a loop all parameters and generate these instructions, and then I merge them into a list. And actually we do not need this code at all. We can now just say Elna list append, and the first argument is actually the instructions, I think, and the second is the new instruction, current instruction in this case. The one thing that I forgot, we have to initialize this list, so set the first and last fields to nil. So, and this code can be actually removed. We do not need this. So after that, my body list will contain the same what this parameters variable has. Actually, if I will compile the compiler now, it will crash most probably. Yeah. It does not crash, but the final validation, it doesn't pass the final validation, so the generated code is garbage. And to fix this, we want just to pass this body list first. So we get the generated list, we want to pass on this concatenate function, and something is wrong. Let us try it a bit differently. What if I assign body list first to the parameters variable? It still does not work. Of course, body list is not a pointer, but just the data structure. My compiler does not have yet a proper type checker, so a lot of errors are not really that well readable, but I will implement the type check and error checking at some point. But at first I want to have some more more usable features in the language and in the compiler. So that compiles, and the final test probably passes. Yes, it does work now. Now we can replace this parameters variable with this stuff. It doesn't work because this is wrong. And actually we do not need this variable, this parameters variable at all. We can remove it. And we can remove it from here as well. So the declaration. And now I want to switch the names of these two variables. I want to remove, rename body to something like old body. There is actually only one place where it is used, and we call it old body. And we rename this body list to just body. So we initialize it first and then pass it as the first parameter. And that's it, I suppose. For the parameters we can remove this comment, of course. We do not need this anymore. We can rename this current instruction to just instruction. Okay, and we can remove unused variables. This is actually only last result is unused, and current instruction is called instruction. And that's it for this function. So after that we call parameters. Parameters is fine. This one writes the symbol table, the intermediate representation symbol table into the backend table. It doesn't generate any instructions. The next function we are interested in is actually this ELNA RTL instructions. And this is pretty the same. We have just to pass in the first step. We just want to pass a new variable to it called instruction of type ELNA list, and we will pass this RTL instruction. We will pass this body to it. Or I probably should define a new variable first. No, it should be fine. I thought that in the first step I could probably split the parameters and the body instructions, so I don't mix them or merge them in the wrong order, but actually I think it should be fine if we just pass this body variable to the RTL instruction functions. And just let us look what we do here. So this function calls only ELNA RTL instruction, and our instruction variable should be passed further to this ELNA RTL instruction function. So instructions and instructions. So this next instruction assignment can be removed because it is reassigned later. After that, we want to remove this ELNA list initialize because it is initialized in the caller, and pass to this function, and then we can remove the remaining block and set the next instruction to the last instruction in the list, and we return the first instruction. And then we can remove these allocations, this allocation, because it is always allocated in the caller again. And if we save and compile it, then the final test will pass, meaning that it doesn't print anything. And that was this ELNA RTL apparent value function. So, and now we can look at the callers of one of these functions, like, or let us begin with the simpler function, probably with this unary, ELNA RTL unary thing. So it is called twice in the same function, and we do the same. We introduce a new parameter instruction of type pointer to an ELNA list. It won't need this list as parameter then, it shouldn't be initialized. We pass this instructions list to this function first, and then set the result. Actually, we do not have to set the result anymore. And then we set the next instruction to a new instruction, and we set result next to this new instruction. Instead of that, we will call the procedure that actually does the same. Append instructions, and next instruction is actually the thing that we want to append. And the result variable isn't okay, it is used here for returning the value, but we actually do not really need this. We can just return instructions first. So, and here we will need to pass the body variable to it, and here too. And now we want to set the result to the appropriate value. This actually means that we do not have to return it. So actually I have a few places where I set the type of next instruction. Let us find one. This is the proper type, and then we can replace that with a real type. And here I still have the result variable copy operand. Oh, it copies one operand from TIC to result. So I can just pass instructions first to it, I suppose. And we have the same thing also here. Okay, that looks fine. So let us go to this RTL unary. We do not return anything, and we also do not need the return value from this operand value procedure, but okay, we do need the return value here, but I actually think that I do not use it anymore. So if I just do not set them and run the compiler, it probably should pass the tests. Yes, it does. So we can remove these local variables, and we do not need the return value of this. Let us check other cases. It isn't used at all, so we can remove the return statement from the end. It isn't needed anymore. Okay, it doesn't have something like next instruction, no. But actually another thing here, I actually want to get rid of this next instruction thing, because we do not need it Either I can just say that next instruction is in this case just body last. This is the point of this change, that we replace all this next instruction. Next instruction is a bad name. It is the last instruction in the list, so the sense behind this change is that we replaced all these next instruction parameters just with one data structure that represents a list of instructions, and we can then remove this next instruction thing, I suppose, and go to the unary once again, so it isn't there anymore. So we need to define a variable instead of this next instruction because it is not a parameter anymore. So we call it just instruction, and I don't know what its type, probably just word instruction. Yeah. Oops, it is an RTL instruction, a pointer to it, and then we rename this next instruction variable and append it. Now we go back to this operand value function and look where else it is used. And the next procedure is this LNRTL store procedure. It is used just once. And the first thing that we do, we add a new argument to it. And we remove the initializer here and replace the body variable with instructions. So we won't need this stuff, and we will need an additional instruction variable. We can use one of the available variables, and let's say that we assign this store instruction to the result variable. We remove this thing, and then we set the operand value on the result, and after that we check the kind of the TIC instruction, and we set the second operand if needed. And after that we need to append the result to instructions. RTL star, it is used here, and we need to set the result to I do not pass the instruction list. I think it is called body, and the result is then body first, and next instruction is body last. Of course, we need to replace body with instructions everywhere. Okay. Oh, of course not next instructions, but next instruction. Then we can compile this stuff. Okay, that works, and now we can remove the old code, and we do not need to return anything anymore. So the operands aren't used, I think. So this variable can go as well. And I actually want to rename result to instruction, because it is not a result anymore. Okay, that looks fine for this function as well. So no, it is not fine. We still need to remove the next instruction argument, RTL star. I add this result and next instruction as assignments in each branch. We will remove them later. It is just for migrating each branch one by one, so that we do not change the code of other branches that can break something. So we go back to the RTL load operand value. And so this is this RTL binary. Unary is the function we finished, and this one is done as well. And then we have this RTL load function. Let us migrate this one. So this is the declaration. And it is used only once as well. So the migration should be doable. We say that this is an ELNA list pointer, and we pass the body to it. This is the first step. We do not need to initialize this body here, and we use the instructions instead of the body. And we assign this value to operands, but actually this is not needed, so we can remove this block of code. And result is the thing that is returned, and I do not need this stuff, and I do not need this thing as well, but I need to assign the instructions first to the result. And of course, after generating this instruction, I want to append it to the list. But not the result, but this next instruction. Okay, let us remove first this code, and then this stuff, and this one. We can switch it. It belongs together, and I do not need to save it. I can just return it right away. Then I do not need the result and operands variables, but we will need one variable for this next instruction. It should be enough to migrate the color side, so we can just copy paste this code as well. We don't need to assign it to result, and that's actually it for this load function. And now we can remove this next instruction parameter, and we remove it from the caller as well. And we use it instead of next instruction. 1 second. So next instruction, and we write here just an instruction, and of course not as the referenced pointer. So this actually looks fine, I think. And now we can remove the operands variables, and we can remove the return statement. Okay. RTL operand value. So this is done, this is done, this is done, and it seems that that was it. So the last function is this one. It calls elna RTL load operand value twice. This should be actually doable. So elna RTL binary operands. It is called 1, 2, 3. 5 times, more or less. Yeah. Okay, so the first step, we add this instructions argument. It will have the type pointer to an elna list, and what we do, we actually just pass nil at first to this procedure. Okay, and for compatibility with other colors, we will do the same that we already did. We just check whether the instructions is nil, and if this is the case, then we just allocate memory. So we say that instructions is malloc size of elna list, and we initialize it in this case. So we write here instructions, and I do actually need to replace this body variable with the instructions pointer. Okay, now we can fix the places where this function is actually called. And we will probably, so binary arithmetic, binary equality, binary operands. Yeah, whatever, let us start just here. So this is greater or equal instruction that is translated from the 3-address code into assembly, and we pass the body variable to it at first, and then it creates this intermediate instruction and it sets the operands for these instructions. And actually we can also split this thing and say that operands is just body first. And next instruction is probably already instructions last. So this is fine. Then we create this instruction and then we set result to the last instruction in the body, and we set it next element to the intermediate and set intermediate to the next instruction. So basically what this code does, it does two things. It appends ELNA it appends this intermediate instruction to the two other instructions, and it assigns, or probably just remove it all, it assigns the instructions last once again to the next instruction. And of course it is body. And this one is of course body as well. So this is fine, this can be removed then. What happens then? Then we create yet another instruction and set it operands. Then we append it to the list again, and that's all actually, and set the next instruction again. So it's actually the same thing. We can just copy these two lines and we can say that we append append the result instruction to the body, and then we update the next instruction reference, and that's it actually. So, but the result should be the first operation, so it is operands here. We can actually just assign result with this thing, and we already set the next instruction, so there is nothing to do else. And now we do not need to set this next instruction each time. It can be done only once, and we do not need even multiple variables. I don't think that this function has an instruction variable, but it has this intermediate instruction, and instead of result we will use this intermediate instruction variable, because it just describes the purpose of this instruction better, and it should be possible to compile this thing now. So let us move to the next branch. We need branches that this binary operands is used, and it is used in less or equal. Somehow I have a feeling that this stuff is almost the same. Greater than, less or equal, greater or equal. So it creates basically the same set lesser than, but it sets instructions to the to different values. I think. Oh, it is greater than. We need greater, less or equal. Greater than. Greater or equal, exactly. So it creates an instruction. It creates also set less than. It uses almost the same registers, but the 2 and the 3 are swapped. But otherwise it's almost the same thing. I wonder how I can combine them. And here's then XOR called. Here is the instruction, copy operand. But well, let us rewrite it first. I actually want to save my progress so far, and then we just pass body to it. Then we create set less than instruction, set the operands, then we append this thing and remove other instructions, then we create a new instruction and we use intermediate instruction here as well as variable name. So and now we just need to finish this and we can remove then this stuff. Okay, this is done as well. And now RTL binary operands. Where is XOR used else? So greater or equal and greater or equal and else or equal probably, yeah. We have a bunch of procedures that generate this binary, that calculate this binary expression results. RTL binary equality, for example, is one of them. Then we have this binary arithmetic, binary operands. Is there something like binary comparison, binary arithmetic, binary equality? And let us just define here one more procedure. Of course, we will name it with some bad name like comparison probably, and this procedure will take the instructions as its first argument. It will take the TIC instruction. So this is this will be an ELNA list pointer, and other than that, it will take two registers, being LHS and RHS, both of the type ELNA RTL register, and here Okay, we cannot work this way, so let us swap the halves. Okay, and this one will be an Elna RTL register as well. And we can actually write it just in 2 lines so that we break the argument line here. And the content of this function will be this all. The one difference is that it won't set the result and it won't set the next instruction. It will just append the intermediate instruction to the body, and body is actually an instruction list called instructions. And we will define a new variable instruction, and it will be an Elna RTL instruction, I suppose. It should be probably be a pointer. Okay, and here we need a next instruction that we do not really use as a temporary solution. Let us just pass a pointer to instruction to it, and then we need to rename this intermediate instruction to just instruction, and here as well. Okay, at least it compiles without any syntax errors or similar stuff. The only 2 arguments that we have is lchess and rchess, and we put them just in here, LHS and RHS. And now we can replace this code with a call to this function. So we call Elna RTL binary comparison, and we pass the body to it. We pass the TIC instruction to it. I hope it is called TIC instruction. Probably not. It is called just TIC instruction. We do not need this next thing, and the only things that we do need is actually the registers T3 and T2, I think exactly, and that's it. After that we can remove this stuff, and we just need to set the next instruction to the body last and result to the body first, but other than that it should actually compile. I think Elna RTL binary operands does not really use this next instruction thing. Yeah, it just sets it. Oh, I replaced the target register instead of operand register. This is T2 is the target register, T3 and T2. I pass them in this order. T3 first and then T2. And actually this one should be T2. And then we have LHS and LHS. That makes more sense. Yeah, it does work. Now we defined these functions so that we can also replace this branch with it. And if I'm not completely wrong, everything that we need is just to swap the registers here. Exactly. So unfortunately I haven't finished even such a small task as migrating the list implementation from a simple single linked list to a list that tracks its last element. But what can we do? I did some work, and I also removed some code and unified some code so that the repeated code went into a procedure that is called, and I will look that I replaced the list implementation in the remaining RTL functions, but this is a job for a different time, and I will end the video here.